All right, we are going to learn how to visualize some GIS data in 3D. This is fun and it's pretty easy. In fact, it's so easy, sometimes maybe people are tempted to overuse it, but it's worth knowing how to do. I trust your judgment. Just like everything else we do in GIS, this is divided into two paradigms. We can visualize vector data in 3D. That's called extrusion. And the heights above ground are determined by the values in one of the fields in the attribute table. And then separately, we can visualize rasters in 3D, or, and this is a little subtle, vectors based on a raster surface. And we'll learn how to do that second. But let's get started with the easy stuff, which is vector. I have this project package for you. It's not that exciting. It's just some census tracts and a variable about whether or not houses in that tract have complete plumbing. So that means hot and cold running water, toilet, and bath. So we're going to open in ArcGIS Pro, click the P item, and I already have it here because it takes too long to load. So you can pause the video and get it ready to go. Let's just very quickly explore the data. So we can open the attribute table. Uh-oh, there we go. Let's open the attribute table. And this is the result of a join. So I did not take the time to clean up the table. We have all the identifiers for the census tract. And then you can see I had to make a new GeoID to be the join key field. And then I joined on all these statistics about the total number of households in each census tract, how many have plumbing and how many lack plumbing. These should add up. I'll very quickly verify that by hovering over the top of one of these, they have the short field names. They are not encumbered by the join origin. And so this is good data ready to go, stored in the geodatabase, a real feature class. All right, so 3D visualization does not happen in the map. We have to add a new type of map called a scene that enables 3D. To do that, let's go to the insert ribbon. And then here for new map, if you pull down this little tiny triangle, we have a couple of options here. I'm not going to show you a global scene, but sometime go in there and experiment with it on your own. It's kind of fun. You actually get a little model of the world and you can show your data like shooting off the side, like porcupine spines. But this is such a local project. Connecticut's such a small place. I'm going to have us use a new local scene. And this will just be the local area. When your scene opens, you get a base map and it's visualized on like a base map elevation system. You're welcome to explore this. You can change the base map if you want. In another video, I think I may have introduced you to this navigator, but I'll just quickly review it. You'll always want to click the up caret to show full control. And then this inner ring can be dragged upward to tip the world. And then this outer arrow changes compass direction. So it gives you some navigability. Generally, I find the base map distracting in a scene. Not only does it slow down the 3D rendering, like if your computer is borderline on whether it can handle this, but sometimes like the layers of the base map will get interspersed with the layers of the data and it looks really messy. So my practice is to turn off the map and the world elevations and start from scratch. How do we start from scratch? Well, you can add data to a scene, but generally I've been working in a map and I've developed some sort of symbology that I like. So in order to preserve that symbology, when I move over to a scene, I'll copy paste it. So I'll do right click, right click, no, right click. Sometimes I have a hard time right clicking on this computer. Copy, and then go over to the scene and paste. And it takes a while to draw because 3D is kind of heavy. There we go. And right now, Connecticut is flat. It looks completely flat because we haven't told it what elevations to use. For vector data, as I said at the beginning, let me just hide the zoom controls. The name of the process of putting this in 3D is extrusion, E-X-T-R-U-S-I-O-N. And in the feature layer, if you've highlighted the layer in the table of contents, and you go to the feature layer menu, there's a whole little neighborhood over here called extrusion. The first choice you have to make is what type of extrusion. Right now, there's none. That's why it's not 3D. There's sort of no wrong answer here. You can choose any of these. You can read about the differences among them, but basically, in a nutshell, it's if you have a terrain like the actual hills of the world, and you want to build towers that show some variable, do you want them to sit on the terrain? Do you want them to sit on the flat base? Should they be tipped? I'm not using the base map terrain, so there's, again, no wrong answer here. I tend to go for absolute height, but you can use any of them. And still nothing happens because we haven't told it which field to use for the heights. Now, let's go into this field choice and take a look. We have the total households, has plumbing, lacks plumbing. Connecticut is a pretty well-developed place. So almost all of the houses have plumbing. If I choose has plumbing, I'm going to get 1678, 1723, 2009. I mean, there's not going to be a lot of variation. And again, you're going to be seeing the number of population, the number of households. So just to get more contrast, I'm going to look at lax plumbing instead. Lax plumbing has numbers like 0 to 46 to 125. There's smaller numbers and the variation looks greater. So let's do lax plumbing. And it redraws. And every time you visualize in 3D, the first time you try it, one of two things happens. It either still looks flat, or it looks ridiculous, like it's these big, long towers of green spaghetti. In this case, it looks flat because the units of height are meters. And if the numbers I'm visualizing are 0, 50, 100, in comparison to the kilometers that make up Connecticut, you're not able to see those little heights. They'd be like buildings, right? So one thing we can do is change this unit. We could try, instead of meters above the surface, we could look at kilometers above the surface, just because I want you to see the green spaghetti, really. Oh my goodness. And you know, that happens. So maybe kilometers wasn't a great choice. Instead, let me go back to meters. You could try the other units too. And show you what this formula box does right here. This is a Greek letter chi, and it's supposed to represent that you can set a formula for the height that's based on one or more of these fields. So if I click that, I get a box, and it's in Arcade or Visual Basic. I honestly don't use either of these. I'll just leave it on Arcade. I wish they had a Python choice. And you see that the field that we're extruding is lax plumbing. You can multiply this to make it bigger. So maybe lax plumbing times, well, 1,000 was the kilometers. That was too high. Let's try 500 and see what that looks like. Yeah, still pretty tall. Let's try 200. Okay, that's kind of more realistic. Now we can see high spots and low spots where there are buildings that lack any sort of plumbing. I think we should probably normalize it by the number of structures. So the other thing we can do, oops, hold on, let me come in here, is instead of multiplying it by 200, we could divide it by one of these fields. Let's divide it by the total number of households. And that's going to be such a small number that I think we should multiply it by quite a bit to make it tall enough. Let's go back to 500 and see how that looks. We may need even more. Actually, maybe I should do 1,000. Let's just try that. So now we're going to see a rate. Yeah, that's still very, very flat. All right, let's put a bigger multiplier in there. Let's try 10,000 because these are going to be small decimals. Maybe everyone should try 100,000. What's going to happen? It's going to be too big. Hey, that looks pretty good. Ooh, look at that one. What the heck is that? I don't know if the identifier works here. Oh, it'll just give me a census tract number. It's somewhere in Hartford. Maybe it's like the park or something. Anyway, this is a visualization of the rate of households or buildings with no plumbing or inadequate plumbing. One more trick I'd like to show you is how to get rid of these gray walls. I think they tend to look a little bit messy. Those are caused by the gray outlines on the polygons. So if you go into symbology and we change the symbol, actually, you know what? Instead of single symbol, let's show something else. Let's, in color, we'll show the number of households lacking plumbing. And in height, we'll show the rate. And again, I could change this. Maybe I don't like natural breaks so much. Okay. Well, that's a nice thing to be able to do, to be able to show the absolute number versus the rate. And here they look pretty similar, actually. You can click on more here in the bottom part of the symbology panel and format all symbols. This will change some characteristic that is true about all the symbols without changing those quantifying colors. So I can go to properties. And here's the outline color, they're gray. I could either give them no color on the outline, or I could reduce the outline width to 0, and then apply that. And take a second. And it just cleans it up. It just looks better. Oops, no, I didn't want to go that far in. Wait, go back a view. I just want to zoom in a little bit. There, that looks really nice. And what we see is the rural areas out here and over here have the most buildings with inadequate plumbing, and that could be like farms and camps and things. And then interestingly, in some of the cities, this is Hartford, this is Waterbury, this is Bridgeport or New Haven, I can't tell from this angle, I think that might be New Haven. There are buildings with inadequate plumbing. So very interesting. I had not put this in 3D before, and I'm very curious about that one spike in Hartford. So you can even add to your understanding of your data by visualizing it in 3D.